Okay, well, welcome back from the break, everyone. And those still coming in, I appreciate it. So I'm really excited to be able to moderate this panel discussion immediately after the fantastic presentation, keynote presentation around POSE. David took a lot of the intro that I was going to provide about what POSE is. So I think we all have a good understanding. And he also cleared up that it's called PESOS versus PESOSE, which is something that I had already also heard. PESOS, PESOSE. So as you know, the NSF POSE program has a remarkable history of funding roughly 140 awards. Around a dozen of those have come to the University of California system. And so as we heard, POSE takes a research project and it thinks about how to scale this up through the development of managing organizations that are focused on governance, that are focused on security, coordination, and explores how it can become something bigger, something that is a sustaining open source ecosystem. And so as I mentioned, nearly a dozen of these projects have come from within the UC system, and so we're really excited to have representatives here from 5 different projects, PIs that have been involved and funded through POSE, so they can talk about their experiences. We've asked them to share what their projects do, who their communities are. We've heard about the communities, how the POSE funding has changed their approach, and what sustainability looks like for them after the end of the award. And so here with us this afternoon, or this morning rather, we have Jarrod Millman, who we've heard from already. Jarrod is the senior open source scientific Python developer at BIDS, Berkeley Institute for Data Science, and he is the executive director for the Berkeley's Open Source Programs Office. His primary focus is on developing and sustaining open source, community-owned scientific software tools, and his POSE work supported development of such an ecosystem for scientific Python. We also have Harikrishna. Harry is a PhD candidate in computer engineering at Santa Cruz, and his research explores optimization and democratization in machine learning. He's worked with many open source frameworks within deep learning and network simulation, and as part of an NSF POSE program, he co-created NSB, a network and systems co-simulation tool, and he had the opportunity to participate in one of the NSF iCore programs. Also joining us is Stephanie Lieggi. Stephanie is Executive Director of the UC Santa Cruz Open Source Program Office, and she's Chair of the OSPO Network. She served as Principal Investigator on POSE Phase 1 grant for Skyhook Data Management, which was a cross-incubated project that embeds data management and processing into distributed storage. Fourth up will be Sanjit Seshia. Sanjit is the Cadence Founders Chair Professor in the Department of Electrical Engineering and Computer Science at UC Berkeley. And his research interests are in formal methods for dependable and secure computing. And his project was focused on scaling up Scenic, which is an open source language and toolkit supporting systematic methodology for AI systems. And finally, on the end, we have Andrew Kahng, who is a distinguished professor of computer science engineering and electrical engineering and a holder of the endowed chair in high performance computing at UC San Diego. He is the principal investigator of Open Road, which is a project that is designed to make chip design more accessible through 3 open source tools. And Open Road was initially supported by DARPA and has recently been funded by the NSF program. So we have 5 POSE program recipients here that are going to talk about their experiences. We have presentations from each of them for approximately 4 minutes. I think one individual has slides, but mainly discussion-based, and then we'll move into an open Q&A. So the intent is to have about half of this session be dialogue and discussion within the audience. And so with that, I will pass over to our first speaker, Jarrod. You have 4 minutes.
Okay, so I ended up spending my time this morning working on my opening remarks, but that was because yesterday I was working on a NSF Safe OSE proposal, which is very related to the POSE proposals, and I think both the POSE and the Safe OSE and the newly named PESOS are really exciting funding opportunities. Traditionally, a lot of the funding that you get from a a national foundation like NSF really had to do with novel features, new developments. There had been, like, NIH had a program several years ago for continued development and maintenance, but I think this is sort of, at least that I'm aware of, this sort of first one that thinks about governance and community, these two. And I think, as you've heard in this room several times already, open source, a lot of it is more about community and governance and building collaborations than it is about the specific code. And it has to be code, but without the community and governance and other aspects of it, it's hard to get new maintainers on board without onboarding materials. It's very difficult to deal with conflicts when you don't have clear governance, and instead just becomes a bunch of personality discussions, which can become very unpleasant for everyone involved. So I'm very happy with these programs. In the scientific Python ecosystem, which I care quite a bit about, its proposed funding has gone for several projects that I know of fairly well. There's the M&E Python project, which is for MEG and EEG analysis, and that's been a really huge boon for them. Also in the PySail community, which is, I think I mentioned earlier, a geospatial analysis library. That's been very helpful for them, and as part of that, we host at the AI Future Labs, which Kirsty mentioned earlier today, a summit where we got to talk with a bunch of people. There were end users, there were core developers, there was educators, and bringing that group together in a community setting is not something that's always easy to do in our communities. And even though a lot of open source projects really have embraced distributed development and all these sort of online activities, there's still really no, at least in my mind, alternative than for in-person, face-to-face discussions. And so I think a lot of things can get moved quickly in these regards. I think David maybe is not in the room right now, but his mentioning that many of the open source academic projects really have not a good grasp of like their user community and sort of marketing around that is very, I think, true. I think it's also the case that there's a little bit of a discrepancy on both sides, right? So, we very rarely in our communities that I'm aware of use words like product or value proposition, and so there's some languages mismatch and some like incentive structures that are different, I think, as well. And so I think having them interact with us more in this open source is great. I know that they've also embraced the open source program office. So in the announcement, there's a specific line in there about PIs being encouraged to be from open source program offices to help shepherd standard governance across projects domains. We at Berkeley had a phase 1 POSE award for statistical Python. So I think if you're familiar with data analysis, data science, you're probably familiar with the idea that Python has a large share of that space. And given the importance of statistics in data science, it's kind of a little bit of an unusual problem we have, which is that very few statisticians contribute to Python historically. Many of them developed and contributed to another language called R for historical reasons. It's a great language, but the fact that they're not connected to R is not connected to the bigger data science community, I think has made it so that Python has gained a lot of traction in that community. But statistics, if you take any training, is a very slippery object. It answers questions that you want to answer with answers that don't answer the question you want. And a lot of the thinking is a little, like, I think, confusing. So we've had a problem that in Python, a lot of the stuff's been written by non-trained statisticians. And given the slippery nature of these ideas, I think it's going to really be nice to have Python more integrated. It's also the case that right now there's a transition happening in statistics departments. A lot of students coming in are wanting Python training because they're looking at job opportunities, and there's more job opportunities in Python. Maybe other classes encountered Python. So there's kind of a natural transition right now. The statisticians are starting to move to Python, and we're hoping to capture that. We just got a phase 2 notification that has not given us funding, but we're moving forward. So hopefully in the next week or two, we'll find out about that.
Perfect. Thanks so much, Jarrod. Hari.
Hey, my name is Hari. The project that I did NSF Pose for is called NSB. I'll tell you a little bit about it and then about the community. But NSB stands for Network Simulation Bridge. It's a simple network co-simulation tool. It's actually a nice little wrapper around a low latency, high bandwidth little message channel. But what we used it for is to integrate network simulation into models of connected systems. So there's a lot of different connected systems and connected technologies being developed right now. And on the other side of things, we have really good open source network simulators out there, but no really great way to leverage those network simulators in these complex models. And so our large goal, our big picture goal, is to basically just make that easier, make it easier for people to prototype their distributed applications, make it easy for people to just connect their applications to the networks that they expect to deploy on before they actually spend the money and the resources and the energy to deploy them. In terms of who our community is, I think this is a good question. Right now, our users are mostly academic and mostly within the floor of our building. And that's part of why we did NSF Pose, because before January, we were mostly just a lab project with a few outside contacts who were mildly interested in using the tool. And they saw a lot of potential in it, and that's why we did NSF Pose. Our contributors right now are mostly undergraduate and graduate students at UC Santa Cruz. It's still largely core team managed, but we're in the process of involving more user contributors, including from industry. And so, again, I think a lot of what I can share is from this perspective of being in the middle of this transition from going from an academic project into something that is more open source community facing. In terms of what Pose did, what did the funding do? I think some of our team members are here, but we used to joke about this project, about this open source project being everybody's second priority because a lot of us are PhD students. We have our research. Our advisor has her research. So what this funding allowed us to do was finally dedicate the time, resources, and energy necessary to really polish this up into a usable tool, to put out all the documentation, the tutorials, to really build a team that was centered around sustainability, not just achieving the functionality of the tool. And it's really allowed us to learn about how to build a governance infrastructure, contributor pipelines, user pipelines, all that stuff that's necessary to make an open source tool really successful. In terms of what we see beyond, in terms of sustainability, right now we see, I think David had mentioned this aha moment that one of the teams he mentored felt, where sustainability and success was in integration into the ecosystem rather than just innovation. And we really felt that we're trying to position NSB, our open source tool, to kind of be a ubiquitous framework. It supports a lot of different things, and we've heard a lot of different ideas from talking to all the people that we've talked to. And we think we can provide the support that they need. Beyond that, in terms of how do we make more money beyond that? We know a lot of people have specialized needs for their systems, for their modeling situations, and so we've also considered working with them, establishing partnerships around our open source tool, but helping them develop specialized solutions. So we can talk more about that later.
Fantastic, thank you. And Stephanie.
All right, hi, I'm Stephanie Lieggi at UCSC. Full disclosure, I'm also on the NSB team, but I'm going to talk about my first Pose project, which was in the first cohort that ever happened. So the system and the iCore stuff that David talked about and that we did the last few months was not around. We had a different program, which was not quite as community discovery focused. So it was a much different experience in that period. But the project that we worked on that I was helping in that Pose was, as Amber mentioned, the Skyhook data management, and that was a very interesting project because we actually literally had the bus factor moment because our lead PI had a or the person who was going to be the lead PI actually ended up having to step out of his career for personal reasons. But basically, we had that moment of like, wow, what do we do when we lose our main maintainer? Because guess what? We just lost them. And so we used that period to really understand our community, to see who could take over, like literally at that moment. And we were really lucky that we had, as part of this project previous to Pose, we had been already working with like Google Summer of Code and other activities to bring in new contributors. And one of our lead contributors through that, also we discovered through Google Summer of Code, also became one of our PhD students and kind of took over a lot of some of the work. So though that is not the ideal way of dealing with the bus factor, it worked out for us. And then what ultimately happened with our project was that it became integrated into Apache Arrow. So what we found was, I think, interesting, and I haven't seen this widespread through Pose projects, is the idea of, we actually decided that what made sense for us is to find a mature project that could integrate our work into it. And then the maintenance, not that all the maintenance and activities are just thrown over to Apache now, or Apache Arrow now, but a lot of the work that we had to do actually contributed to them, strengthened that project, but also allowed us to kind of have a wider impact. And I think that was kind of that time, the Pose time period actually gave us the understanding that we didn't necessarily need to be our own thing. And I think that's something that's lost a little bit, like that sometimes people don't recognize it. And the idea of like sunsetting a project and that's actually also a successful outcome of Pose projects, is to understand where you fit in the ecosystem and not just how to build a new one if there's already an existing one. And I think that, I can answer more questions about that.
Thanks so much, Stephanie.
Oh, I do want to say that, by the way, the reason why OSPOs are now listed in the RFP, I did that. I just want to say it, and I have, like, because we weren't, and I complained about it, and then the next time around they were. And I have justification. I've been told that it was because I bitched about it.
Okay, and with that, we're passing on to Sanjit.
Hi, I'm Sanjit Seshia. I'm a professor of ECS here at Berkeley. A little bit of background about myself and my field, and then I'll talk about Scenic, my post project. So I work in a field called formal methods, which is about really creating a theory and tools to make systems safer, more secure, more trustworthy, more robust, and so forth. And so, the tools is a key part of this. We create, a lot of our algorithms and theoretical ideas are implemented in software that is then used by community members in working on different application domains to make their system safer and better. And in my 25 years that I've been a graduate student and a faculty member, pretty much everything we've done is open source. So that's really part of the culture. Of course, it's been part of the culture at Berkeley for decades now. And so that's the context in which we created Scenic. This was in the academic year 2017-2018. So in today's lingo, with today's buzzwords, I'll call Scenic a neurosymbolic system for world modeling for physical AI. So that's how I describe it today. But what it is at the core is it's what is known as a probabilistic programming language. So it's a programming language like Java or Python, but it's probabilistic in the sense that every variable in the program is a random variable. And a Scenic program defines a probability distribution over possible worlds. But these worlds are primarily in our applications, these are physical worlds. So imagine you want to model the Browser Center, a physical space with all the people who are in it, for the purposes of maybe designing robots that might deliver, things, mail around. And so you want to create this model of the Browser Center for that design purpose. Okay, so you could do that in Scenic. That's the kind of thing it is. One of our major applications early on was in self-driving cars to model traffic scenarios. And then have people who are designing and evaluating and testing these autonomous systems use Scenic as a common representation. So that's, these are what people are calling embodied AI or physical AI systems. So the community that we've had spans industry, academia, and also government agencies. So industry that has used Scenic includes, companies in the self-driving car space, robotics companies, aerospace companies, companies working on augmented and virtual reality applications, and so forth. One of the most popular uses of Scenic is to connect it to a simulator, and then use Scenic to drive simulation-based testing and evaluation and development and data generation, generating synthetic data of various kinds. And these are companies ranging from small startups to large companies that are at whose market capitalization is at the high end. Academia includes computer science, people in computer science departments, but also various engineering departments. So we've had lots of academic users. And then government agencies includes regulators, and also DARPA used Scenic in one of their programs, in their evaluation teams. Scenic is now maybe a 8-year-old project. And initially, we were primarily funding the development of Scenic through our various federal projects and industry-funded projects. And then it came to the point where it was quite a mature system being used, and we needed to be able to find a path to sustainable development beyond the university. And that's really when we applied for post-funding as a bridge to such a development. And so the post-funding has helped us in many ways. One is very concretely is to hire staff programmers to help us support all our users better and implement new features and deal with PRs and issues and things like that. Secondly, to support dissemination activities. So we've been holding regular 2-day Scenic boot camps. So this is, I should say, Scenic is something that I co-direct with my collaborator, Professor Daniel Fremont, who's at UC Santa Cruz. He was my PhD student when we started this back in 2017, 2018. And so we've been holding these 2-day boot camps at UCSC every year during our post project, plus doing tutorials at various industry and academic conferences. And then, of course, trying to figure out this path to sustainability. And right now, we're in the final year of our post project, and we have various prospective sponsors, but we're still, Stephanie is involved in this conversation, Jarrod is involved in our conversations. We're trying to figure out what's the right structure for us to graduate Scenic from being a post project to being something more longer term. And I know Daniel spoke to Nithya as well yesterday. So we're actively trying to figure this out. That's, I don't have an answer yet as to what that next step for Scenic will be.
I'm going to call time at that.
Yeah, but that's what I wanted to stop at.
Okay, fantastic. Thank you so much. And we're just transitioning to a few slides for Andrew.
Oh, great. Stephanie. Okay, good morning, everyone. It's my privilege to be here representing the Open Road project. And pop quiz, how much does it cost to design a chip today? Well, I'm in the wrong room, I guess, or the right room. If you told yourself $500 million, of course, well done. And whether it's the Semiconductor Industry Association's Trade Association or ARM's IPO prospectus, many folks are seeing the cost of design as a crisis. So the problem, cost of design blocks innovation in silicon. So then there's Open Road. Open Road is an open source chip design tool. It takes a hardware description, which is something you can send or tape out to a foundry in 24 hours, no human in the loop. It's funded by DARPA for 5.5 years. And Open Road lowers cost and therefore risk for hardware innovators. It's used worldwide by researchers to train tomorrow's workforce. And importantly, or crucially, there is a company called Precision Innovations that has developed and supported Open Road on a commercial basis since 2019. The management organization for Open Road's ecosystem is a 501c3 called the Open Road Initiative. And through the lens of sustainability, the most important users are the commercial entities who pay for support and enhancements. So, for example, hyperscalers use OpenRoad especially for early, fast design space exploration. Supporters more broadly include strategic backers along with star customers. And on the contributor side, producers are the paid, accountable architects and maintainers of OpenRoad, the builders who keep the tool ready for industrial adoption with paid support. And there are other kinds of contributors, power users, influencers, and enablers as well. And there's flows of money, electronic design automation technology itself and people, and adversaries, including saboteurs. How did the POSE funding impact OpenRoad? Above all, being awarded a POSE grant forced us to develop and acknowledge this picture. And the I-Core for POSE training was basically a gigantic kick in the pants. Out of 103 stakeholder interviews, 40 plus were in the commercial chip design segment that we believe is our key to sustainment. We got many new insights and reality checks, like, well, including your onboarding actually sucks, please fix it, and so on. But for OpenRoad, sustainability comes first, and it will be all about product tapeouts and foundry support. So OpenRoad will sustain itself in the future when people are able to bet their companies on it. And the foundry is the gatekeeper for the use of any chip design tool with that foundry's technology. So support from the foundry is a must. And dollars matter. Precision actually has 30 employees today. And I have zero interest in that company, by the way. We also learned that, governance transcends. Did something happen? Governance transcends who controls the key decisions and the roadmap. So these and, or and, those are important. We found that it's okay to prioritize control over community, actually. And as long as governance is well-defined and transparent, it works. And so this is a very fraught world of semiconductor design. It's IPR, landmines everywhere, ITAR, OFAC. And I'm happy to discuss this with anyone who's interested, how we as a UC system could collectively learn to navigate this kind of an increasingly fraught, geopoliticized world better together. Tell me if you're interested. And thank you for your attention.
Okay, fantastic. Thank you for our panelists so much. I appreciate those introductions. We have about 20 minutes for questions. I have some questions that I'm excited to ask, but I want to make sure the audience has opportunity. We have two microphone runners either side of the audience, and so while they are looking for hands raised, I'm going to ask the first question. But I should say, when you ask a question, feel free to direct it to an individual or to the whole panel, and be clear who you are directing it towards. I don't think there is necessarily a need for every single person to answer the same question the same way, as sometimes happens. So if you want to pass, phone a friend, you can do that too. Okay, so the question I have for the full panel is that the UC system, we're here because we're talking about UC OSPO, UC Open. The UC system can be both an asset and a constraint. It's supportive of innovation, but it also has a complex structure. How has being a UC campus shaped your open source project? And I'm asking this of everybody, but if the campuses that have two individuals want to just phone a friend, they can.
I don't know how to answer this question. No, it's okay. Yeah, I think one of the advantages is being at any university, which is that there's a lot of innovation that is happening. There's a lot of people in need of tools, so you get a lot of good perspectives and insights locally. I think the same reason can be said why it can sometimes feel limiting. Academia, and especially the university setting, is a really busy and, as he said, complex place. On one side, you have the logistics side, which is licensing, and as somebody who's new to open source and very new at all of this, that is really complicated for me to understand. That's why I lean on people like Stephanie and other people. in the OSPO office to navigate through that. On the other side of things, the academic side of things, it's often hard to really land who your users are and who you kind of leave university and academia and search outside of that as well. Academics tend to be really busy. There's a lot of projects going on. It often is really hard to get responses. And once you get responses, it's hard to get action, like actual usage of your tool or actual time set aside. So those are some things that have made it a little complicated.
So I'll just talk about one item, which is hiring. Being at a UC and being at Berkeley, it's a magnet for talent. We have access to some of the best talent in the world. But our experience has been that hiring with UC processes is slow and cumbersome and has in many ways actually held back our post project. So that's been a negative, but on the whole, we've been being at Berkeley is of course a great draw for a lot of people to be associated with the project.
I'm not at Berkeley, sadly, but I would say that being at my campus has inculcated this mindset of playing defense first and foremost against the various organizations that may coexist in a campus. So, for example, baking in as a statement of work requirement permissive open source licensing of OpenRoad was extremely important because that cut through an enormous number of commercialization or disclosure or background IP, et cetera, landmines that could lay ahead. Getting Precision Innovations luckily stood up and steering a lot of money to avoid overhead to that entity in terms of hiring professional staff. That was very important. It stretched our dollars by about 50%. And then engineering a kind of feasible solution space where code bases were licensed under research licenses or donations of code bases were accepted by the university in advance of the project. Those kinds of things had to be worked through, but once they existed, the university stood behind all of that.
Great, thank you. Do we have, yes, Vesela.
So my question is to Stephanie. How did you establish that the Apache Aero Incubator was the right place for your project? And did you have to meet any particular requirements to become part of it?
So I was the technical lead on that. So I don't have all the details, and but I could find out more on that those steps that actually occurred. But I know that a lot of the connection was because one of the companies that we were working with, Voltron Data, and one of the other firms, and I don't have my notes, but we're working in parallel with that particular project. And so because they saw the connections, that helped make the connection between what we were doing, or what our technical team was doing, and what Apache Aero kind of saw as a potential connections. So the work actually was done by one postdoc and then one PhD student, and they connected with Apache Aero as well as the industry folks to kind of working together to make it like that transition very clear. And there was definitely some prep work. There was a lot of code that was removed because it was unnecessary. I can't remember the number, but the reduction in the amount of code from what Skyhook DM was before and after was like, I feel like it was like 40,000 lines. It was something ridiculous number that once somebody who actually had a good idea from an open source project looked at what had originally been done, they were like, yeah, let's clean this up. So that type of stuff was done in collaboration with the PhD student and the postdoc. Yeah, I know. I think those were kind of the main things that we had to do, like making sure that what the product we were giving them, what we were giving them was good quality. And then this understanding that ultimately, yes, there's still a level of responsibility on the side of Skyhook DM folks to continue the community and the maintenance, but a lot of that started to transition from the UCSC-based folks to the industry-based folks. And so that was kind of where our transition was. Like I said, it wasn't this, I don't think it's like the typical pose ending, but it was actually a really good one for the project we were doing and the community that we had.
So, hi, here.
Oh, hi.
I've been a long time industry person, over a quarter century of open source across large range of companies. I'm hearing POSE as a mechanism by which open source becomes sustainable at UC in general for the country. What I'm not hearing is there awareness, is there lack of awareness or missing practices, mentorship, guidance, recommendations? Because there are standard things that we do in open source. Hey, grow your contributor base, improve your responsiveness, get your README better, make sure you are getting started. 5 minutes to AHA is done very well. Are those practices standard practices? Is there lack of awareness? Are you following those? What is missing?
I can start real quick. Well, one is the ICOR, POSE ICOR, there is a good section on that discussion, and at least the one that we just went through. We have some cool people that come talk to us. And I think in our section, because I knew a lot of, through my OSPO work, and I do think it's really great that there have been more academic OSPOs involved in the POSE projects that are coming from their campuses, because we know a lot of the things that you're talking about, but we also know the people to connect them with. So I got my Rolodex out and started talking about who are the people in the open source community that you need to talk to about this issue. And that helped a lot. So those 100 interviews that we had to do included not just people who would be customers or whatever, users, but also people who knew about governance and open source projects, who understood foundations and how they worked. And so in our case with NSB, and sorry, I'm talking for your project now. In our case for NSB, there was a concerted effort, because we knew what weaknesses we had, to focus on open source communities that were in existence that could help us learn, we could learn from. So yeah, long answer to that question, sorry.
We have a question here, and then on the second row over there.
It's really hard to predict the future, especially when it's all chaotic and dynamic, but sometimes you can predict the future when things are conserved or they're monotone. So I'm curious if you have guidance about the future sustainability of open source projects. There will always be downstream users with new problems, and sometimes those problems are going to be shared by many different groups of those downstream users. There's going to be upstream builders that might be sometimes disconnected from those downstream users. What's the way to bring together the need expressed from the downstream users into the conversations with the upstream builders and generate funding to pay for that build?
I was ready to answer to that until you said bring in funding. That's no, I don't have a good answer. Yeah, so I think, I'm sure this sounds trite, but I feel like this is a very, the moment for open source is more flux than I've ever seen. I felt like, I started paying attention in the late 80s and got more involved in the 90s. And it seemed like there was a clear trajectory that, that's like Gandhi quote about first I can't remember, they reject you and eventually you win. But now, especially with the agentic coding, how that's going to transform programming, coding, computer science departments, how that's going to, impact core libraries maintenance, seems like it's very unclear to me now. I feel like there's lots of opportunity. There's also lots of, I think, obvious risks and fears, because I think it's going to be disruptive. This user stuff, though, I do wonder if it gets good enough, how hard it's going to be. That sort of difference between user and maintainer, which I've never really liked. I've always had this vision of the future being that, scientists, especially I'm interested in scientific computing software, that scientists own and maintain their own infrastructure. I think that might actually become an easier sell when people are able to maybe avoid some of the technical complexity that maybe isn't inherent to an idea in a scientific research. So Yeah, I think there's lots of things that I would love to have, and we've talked, Kirsty and other people at BIDS, about trying to convene people in this space, because I think it's really important for, especially the open source community side of things, to think about this and have discussions about it before things transition at our feet.
Maybe I'll add a perspective from in the context of our Scenic project. So Scenic is has many different users from different domains, quite different domains sometimes. So we have users in aerospace, and there are users in automotive systems, and we've got users into industrial robotics, home robotics, and so on. And they all have many different use cases, and they all bring their own simulators and things like that. And so the way we've tried, we don't have a solution really, I think we're exploring, but the way we've tried to match users' needs to developers is through working groups that are specialized to these areas. And then those working groups meet online, and we try to bring those requirements to the developers that way. And then that's in addition to the standard, people submit PRs, people submit issues online, and then also during our workshops, we have many of these people participate, and we can surface some of these things that way.
I would add that one missing ingredient, maybe to both of the last two questions, is people often fail to understand the cost of developing and maintaining a production quality, industry strength software project, whether open source or closed source. And I think the secret of Open Road, frankly, was that somebody 9 months in said, Andrew, you need an architect. And luckily, Qualcomm, ARM, Michigan, they took huge haircuts. They gave up half their funding. We hired 3 professionals out of industry, and obviously, even if they take 50% pay cuts, they still make several $100K a year. How do you even do that in the UC system? There was a mechanism found, but a lot of things had to happen very serendipitously, and this recognition had to occur very, very early for this project to even become, viable and somehow lasting 7 years so far. It may die, but it's gotten this far just because of that one recognition that you need now 30 people at a small company, scrabbling for balancing the books every month to some extent. And that's a number of millions of dollars per year, even today. So pose is not the solution. Philanthropy or happenstance is not the solution. People have to really think long-term for some types of projects at least.
We're going to take 2 more questions on the second row and the back row, and I encourage our panelists to keep it pithy so we can stay on time.
Yeah, and building on the last question, which answered about half of this, it was really gratifying to hear, Stephanie, you talk about that exit being kind of contribute to an existing upstream project. Both Niti and I were nodding our heads, because this is, even before vibe coding, I take the contention there's too much software out there, too much open source code with overlapping functionality, and not enough collaboration between teams. So maybe even building on those last answers, what more could be done at kind of the academic system level, or even in the way that credit is granted to researchers to encourage greater reuse or contribution to existing open source projects, rather than, it's very natural, right? You start hacking on a thing, it's attached to your paper, it becomes, a software product. How do we catch them earlier in that cycle and say, start building on stuff that's come before, even if it's imperfect or flawed?
I think Nithya is going to talk about that in about 5 minutes too, a little bit on her keynote. But I think that getting the academic communities and the open source communities more intertwined is a huge part. The fact that we knew the right people at the right projects was in part because we were actually going to the same conferences, and I think that really helps and stuff. Or so those type of activities, and then having, that's a total plug for us, but having OSPOs that actually connect the university with the open source communities is a huge part, and having, or OSPO-like some, a entity within the universities that do that, and that's a growing thing. So I think you're going to see it more, and I think it's going to be, it's not going to be just some sort of weird niche thing that I think it's good. I'm hoping that in the end it's going to be the norm, that open source, that the people working in open source in research institutions are looking to their parallel folks in the open source community and being part of those communities, not being just some sort of like add-on thing. So
I'm going to have to ask, we move to this question, sorry.
Following up on the last several questions and responses, Andrew, I was wondering, so you're at UC San Diego focused on Open Road up here. I don't know if you're familiar with RISC-V at UC Berkeley, but those are two complementary open source projects. And so Open Road is relied on POS and RISC-V hasn't. So can you compare and contrast, and how would you, your recent response was making enterprise grade code is different than just open sourcing it. And yet these two are thriving. How do you respond to that?
Well, maybe taking a step back, both RISC-V and EDA software have been questioned, as open source technologies that are possibly playing into the hands of adversaries and so on. So that is a commonality between these two projects, looking back from many years out. We love POS, we love working for the NSF Chips Hub or DOE or DARPA in various projects, because in some sense, we continue the mission driven by the wishes of the federal government at this moment. And so, I know that's not a technical reason or a community reason, but actually we like that aspect as well. And it is part of our thinking, to be frank.
Thank you so much. And I think that is all the time that we have for questions. So I again want to thank our 5 panelists and also thank all of the audience members for your engagement and for the illuminating questions that were asked. So thank you.